It is my distinct pleasure to welcome you all to this 1 hour event during which we, on behalf of the Global CO2 Initiative at the University of Michigan, will talk with you about implementing CO2 capture and utilization at scale and speed. We hope we will present interesting and exciting material to you, and we encourage you to stay until the very end. On the very last slide, we will share access to downloadable report documents. So hopefully between now and then, you will hear interesting and exciting new information to you.
Thank you, Volker. Dr. Volker Sick is director of the Global CO2 Initiative at the University of Michigan. He is Arthur F. Thurman Professor of Mechanical Engineering and DTE Energy Professor of Advanced Energy Research. Dr. Gerald Stokes is visiting professor in the Department of Technology and Society at Stony Brook University. He's former chair of Technology and Society at SUNY Korea and former associate laboratory director at both the Brookhaven and the Pacific Northwest National Labs. He's founding director of the Joint Global Change Research Institute and president and CEO of Battelle Japan. I'm Fred Mason. I'm a former managing director of Caterpillar Luxembourg, and my corporate experience included things such as business economics, investment analysis, startups, strategy, and planning. Jerry and I were both members of the GCI founding team and are members of the advisory board. Volker, Jerry, and I provided guidance and occasional amusement to the team who did the research and analysis incorporated in the roadmap we're releasing today. So our purpose today do we have this slide on the discussion agenda?
I'm sorry.
So our purpose is to highlight key findings that are covered in detail in the report. Specifically, we will explain how we think about CCU. We'll review potential for CCU products to generate negative emissions, and we'll discuss potential levers to scale these products. We will also comment on tech development activities since our 2016 roadmap. We'll focus on near-term opportunities for deployment, and we will recommend what you as a technology developer, an entrepreneur, or policymaker can help do to make it happen. We'll conclude by underscoring the significant and we think exciting CCU products opportunity. Periodically, for a change of pace and to give you an opportunity to participate, we'll conduct quick polls and provide some results. So, Jerry, how do we think about CCU products?
Sherry, we cannot hear you.
Sorry, this report comes out at a very important time. What has happened recently is that through the IPCC and others, the concept of carbon capture and utilization has become a part of what has always been called the all of the above strategy, realizing that we have to, in fact, use a wide variety of approaches to mitigate emissions into the Earth's atmosphere in order to stabilize the concentrations as agreed to under the Framework Convention on Climate Change. As I mentioned, this is important. And our view is that what we're talking about here in the GCI is that it's carbon capture for the purpose of creating useful and valuable goods that, in fact, have a climatological significance. In other words, they do enough of their activity in order to be able to uh, meaningfully mitigate emissions to the Earth's atmosphere. So, what do we mean by CCU? In the next slide, what we're talking about is, can we go back one, please? What we're talking about is capture from any variety of sources, but we're talking about converting CO2 chemically in order to make useful products. And the examples of those products are shown on the right-hand side of this diagram. We're not talking about the use of CO2 as a processing fluid, for example, for enhanced oil recovery. What we're talking about it is taking a waste product, carbon dioxide, and converting it into useful products that have value and a role in the economy of society. In the next slide, we draw a particular distinction about the way in which we see CCU operating. As I mentioned to start off with, this is regardless of where the carbon dioxide is in fact captured. And here we see four places we could capture it from: fossil-based industrial processes. We can capture it from the air or the oceans. And CO2 could be captured, for example, from the fermentation of biofuels. But the question is, what about the products? We distinguish here between two products. The first product is what we call track one. This is the removal of carbon dioxide in a fashion that is almost could be considered sequestration. Regardless of the source, what we're talking about doing here is removing and transforming carbon dioxide into a form that stays out of the atmosphere for more than for 100 years or more. This is a form of what I would call useful sequestration. In the case of track two, what we're talking about is the recognition that carbon is, in fact, an important part of our society. We're not only a carbon based life form, we, in fact, have a carbon based society. We use carbon all kinds of ways, and the principal source of that carbon has been fossil fuels. And so, what we're talking about is using CO2 as a feedstock for those processes that require carbon in a way that enhances what has become known as the circular economy. In other words, we capture carbon dioxide, we utilize it, the process may release carbon dioxide back into the atmosphere, but it reduces the demand for fossil energy. The importance of these products as we look at them, and you'll hear again and again here, is where is the carbon dioxide coming from? Uh, how much of it can we in fact displace? And what is the ultimate fate of the carbon dioxide? Because is what in fact determines the climate impact. In the next slide, um, we're going to start the first of these polls that Fred talked about. And the form will show up in a moment. And why don't you think about answering the questions that we have tried to answer with our product? One is where might the largest source of revenue be, and what might have the largest capacity to sequester carbon dioxide? Take a few moments to answer that, and when we do, Volker will come back with our answers, or at least the start of our answers.
So I assume everybody can see the results. Um, in the question about largest revenue generating capacity, fuels are ranked at the top, whereas the largest capacity sequestering CO2 is placed with construction materials, followed by agriculture and food, actually. So we have been asking ourselves this question for quite a while. And I'm sure that many of you have seen in one form or another the results of our 2016 roadmap that we have published to lay a path for how the carbon capture and utilization economy could grow between back then, 2016, and 2030. And in aggregate, what you see here, also labeled with the track notation that Jerry had introduced to you, the most significant revenue generation potential certainly lies with a variety of products depending on the range you're looking at. And what? I'm sorry, this poll keeps popping up. So if you look at the range of revenue predictions, pretty large margin, not surprising, given that in 2016, this industry was clearly not even at its infancy, but really early in conceptual stage. But it's certainly a point that with construction materials, the opportunity to consume very large amounts of CO2 was projected back then. Of course, in the last 6 years, a lot of things have happened. There is a lot of technology development. There's a lot of political change. There is a lot of business interest that has emerged. And of course, general awareness about what do we do about climate change has certainly changed the landscape for that. So that's why we felt it was more than time to look at this whole scenario again and identify what are the current opportunities, where do we stand, and most importantly, where will we be in 2050? So if we look at this chart and address the annual CO2 utilization opportunities that we have in making key products that are important to us and are used at large scale, we look at that best case scenario, assuming that we deploy at largest amounts and look at what can be done fast. Let's not forget, we have an urgency in this whole problem. We cannot sort of leisurely build up an industry as we have often done in the past. This really needs to happen at speed. So if we look at where are then in this combination of amount and time, the best opportunities, we identified 4 products that stand out, ranging from precast concrete and aggregates as track 1 materials, to also include jet fuel and methanol as track 2 opportunities. And here again, we see that we have significant amounts. If you just quickly glance at the scale here, that even exceeds what we have thought in 2016. So that, in fact, is really good news because we need to handle large amounts of CO2. So let's look at these 4 opportunities in more detail. Understand how fast we can deploy technologies to produce these substances, and what the range of opportunities might be under different assumptions. Let's start with the annual market for CCU products, because at the end of the day, we can only make this work if there's a significant market, so that our premise that we can generate revenue and help cover the cost of CCU is actually true. So if we look at the revenue opportunities, again, in the best case, we'll be optimistic here because we have to be optimistic. jet fuel by far exceeds the opportunities in terms of monetary value, with reaching into the $2 trillion a year revenue range. Precast concrete, aggregates, and methanol still are in the hundreds of billions of dollars, and clearly an industry that is significant. This is not a niche endeavor. How specifically will we get there? It's 28 years to 2050, which is not a whole lot of time. So how quickly can we actually get this implemented? Let's begin with studying aggregates as the largest track one opportunity. And here I'm showing you a graph that is loaded with information. So bear with me as I explain what you are seeing here. We have two y-axes, two vertical axes, and we focus on the left one for now. We're looking at the amount of CO2 that is being used per year. And we look at this value displayed in these colored bars. So looking at those, we see a range roughly on the order of 50% based on how we distinguish between baseline, optimistic, and best case scenarios. Those scenarios are distinguished by industry's willingness to adopt, by the potential price on carbon, and other factors. But we're looking at this deployment with that in mind, and then arrive at a projection for 2050. Again, reminding you, we must be optimistic because we need the amounts to be delivered. We have the opportunity to sequester, in Sherry's words, up to almost 10 gigatons of CO2 a year if we make aggregates. This brings me to these error bars. They seem to be very large, and they are. What they do indicate here is the range of CO2-based aggregates that we can make. The upper limit here given by limestone, that would be composed out of 44% by mass of CO2, whereas other materials would contain a lower amount of CO2. So that is actually of significance to keep in mind, because we cannot always make that products either by the availability or needs of performance metrics. Let's move on to these diamond symbols here that give yet another range. And that range is related to what's shown on the right-hand side with market penetration. So we're looking at different scenarios. Again, the same three cases where in a best case scenario, in 2050, we can capture about 18% of the aggregates market. Now, keep in mind, with these 18%, we already have the ability to capture up to 9.5 gigatons of CO2. This is enormous. This potential is absolutely enormous. How does this look like for precast concrete? Certainly from a track one type material, another good opportunity to lock away carbon dioxide for good. And there we see the growth rate a bit different. By 2050, we expect that the market penetration is on the order of 80%, with far less variability. But we do have significant variability depending on how we actually produce the concrete material. So if we look at an average type value, we're still looking at the hundreds of millions of tons of CO2 per year that we can stick into just precast concrete. We're not even looking at ready-mix concrete here. So this is all good news. How does it look like for track two materials? Well, here, jet fuel, as you have seen in the previous overviews, provides a gigantic opportunity to utilize CO2. But we also have to keep in mind that as we produce and use that jet fuel, the CO2 gets released again. So at best, we create a net zero system, which of course would be a significant contribution to address climate change. And a remarked difference in how fast we can deploy this is seen from what I've just shared with you about aggregates and precast concrete. The incubation time, so to speak, is very, very long. We will talk later about some of the key reasons and what levers exist to accelerate this. But it certainly is some opportunity that will come, and the outlook of significant market penetration is high. Methanol as a track 2 opportunity that we've selected is one example that provides a variety of use cases, including as an energy carrier and, of course, a feedstock, a fundamental feedstock for the chemical industry. So here the deployment is a bit earlier, but still it's taking time. So how do we go about accelerating that, Fred and Sherry?
Well, in looking at building demand and volumes for Track 1 projects, as Volker had noted, CCU aggregates are essentially an environmental double win. They can remediate hazardous waste while sequestering CO2. With a CO2 utilization rate as high as 44%, aggregates can be a large CO2 sink. The challenge then is the cost of the CCU product relative to incumbent products. In addressing the cost, capital investment can be reduced by using retrofit carbonization systems at existing facilities rather than building new. Additionally, CCU aggregates will become more competitive as hazardous waste disposal costs continue to increase. Additionally, they'll become more attractive as concern increases over the environmental effects of quarries. Financial viability can also be enhanced through collaborations to assure supply of mineral feedstocks. In the case of precast concrete, they're interesting because they are actually a superior product to the incumbent product. CCU precast provides performance advantages such as faster curing times, higher strength, and reduced requirements for water and cement. For construction companies, these play out in terms of faster completion times, lower labor costs, and increased productivity. CCU precast production costs can be reduced by co-locating precast production operations with CO2 sources. So, Jerry, would you wish to cover the Track 2 levers?
Alrighty. Thank you, Fred. In Track 2, it's important that we remember what the goal here is. What we're trying to do is to use carbon dioxide as a feedstock that could displace fossil fuels as a source of carbon for many existing industries. So there is a large existing demand for the products that need to come out of Track 2 products. But what we're talking about is transforming a major part of that enterprise to carbon dioxide rather than fossil fuels as the source. What in essence we're doing is we're creating an industry that requires a large degree of cooperation and understanding in terms of what we're trying to do. So the number one is that we have to transform carbon dioxide into its useful form. That requires hydrogen and electricity in order to make that happen. So the cost of hydrogen and the cost of electricity are the number one levers for both jet fuel and methanol. Um, the next point we make here for both of them is that this is an industry-wide. So how industry-wide enterprise? So how do you create the kind of industrial alliances and large-scale facilities that are necessary in order to support the demand for the product out the far end? Uh, Airlines are an important consumer of jet fuel, as we know, but they're not the only ones. We also have the military as a large consumer of jet fuel as well. And that leads us to this point of specialty use cases. We all know that the demands of the military are specialized. And in fact, just to illustrate the point that we've made about integrating facilities together in terms of capture and use, there is a whole class of ships that is used just to provide fueling capacity for fleets at sea. They are called supplementary oilers. The most recent one is named for Ruth Bader Ginsburg, as it turns out. And these facilities basically provide the fuels. We could imagine, for example, a specialized facility that produces jet fuel from captured carbon dioxide on a portable platform, an integrated platform, and the military could be an early adopter. So I think the critical thing here is that as this increasing demand for non-fossil carbon chemicals increases, there are things that need to be done. And those things are in fact critical for moving forward, the most important of which are the cost of hydrogen and electricity. And the other is for the industries themselves to work together in order to facilitate this process. Volker?
Thank you. So obviously, we are excited about the opportunities that lie ahead in utilizing carbon dioxide. And I think all of you online know that we have been excited about this for a long time. But it also is clear that one cannot blindly step into this, expecting that just because we are using CO2 makes this something worthwhile and good. So it is absolutely critical and mandatory that technologies are being rigorously assessed early on during the development, during the research phase even, to ensure that the climate benefits that we expect actually can be materialized. Because if that is not given, it's not sensible to actually proceed with pouring money, effort into the development of such technologies. Clearly, in parallel and integrated with the climate assessment, we must understand, can these technologies be viable and eventually actually produce enough revenue so that factories can operate, that consumers can afford the products? So these integrated life cycle assessments and techno-economic assessments really are absolutely the base for everything to make sure that we're doing the right thing. But as you will see in the course of this presentation and afterwards in reading our reports, the scale of the industry that needs to be built is massive. And it's of course clear that we cannot just go out and put up new factories anywhere where we please. Not only that, I think we have a great opportunity with that new industry to reform and update existing industries and their performance. So this is an area in the assessment world that is emerging. How to rigorously assess and factor in for decision makers how societal considerations need to guide our decisions. Seems daunting, and that's what we thought in 2017 when we observed and found the need to develop guidelines that provide information on how assessment should be done so results become transparent and results are comparable between different studies. Because nothing worse than two assessments of the same products that lead to different results without understanding why that may actually be the case. So we have worked since and continue to work on providing a tool, a set of tools, in fact, that is now compiled and available at the Assess CCUS website that the Department of Energy supported. We have, as I said, started in 2017, begun to develop these guidelines for CO2 utilization. We have expanded our team in 2019 to include several of the national laboratories here in the US and in Canada. And this year we are expanding this harmonization group to include contributors from Japan. So that's a centralized resource that helps teach people how to make these assessments, find resources, find help, and speak the same language, which, as I keep stressing, is absolutely essential. So if we then look, now having the tools to make real decisions, returning to our optimistic view, and hoping that eventually CO2 might become the source material for all of our carbon-based products that we're discussing here to provide the market needs. In other words, our target would be all jet fuel would be made with CO2. All aggregates that we use were somehow embedding CO2 as carbonate, and so forth. So that's, of course, an upper limit, highly unlikely to be achieved. But let's start with what would it take if we could do it. So what you see here is how much we would have to invest between today and 2050, and how we need to look at this in the number of facilities that we need to produce and deliver these products. Let's have a quick look at jet fuel production. Jet fuel production is going to be a 1.6 billion ton a year market in 2050 if we follow the demand increase of the last few years. In order to meet that demand with facilities that we now know can be built, we need to deploy 21,000 factories to produce that jet fuel. Sherry will talk a bit more about this in a few moments, but it's certainly clear that these numbers are daunting. Yet, let's look at this in the perspective of how many airports are there. Globally, there are about 40,000 airports. So there's an interesting implication in these two numbers. Let's look at another extreme for precast concrete. The number of facilities that we need are staggeringly high, 2.5 million. What is this? Well, let's look at how concrete is being made. It's a highly localized, typically fairly small level business, owing to the nature of concrete. It's heavy material, so transportation is expensive, but also especially in the context of utilizing concrete, you cannot produce it and store it because it will cure. Right? So lots of small facilities that have to be built, and there is an opportunity in those numbers.
So I think what Volker's leading up to is that we believe that these technologies are ready for deployment now. That if you look at the spectrum of research, development, demonstration, and deployment, many of the technologies we're talking about now are ready for deployment. Now, the question is, what are the levers to get started? What do you need for early deployment? We all know that getting the early technology into the marketplace, people call it all different kinds of things. But I think the critical point here is that we have come to recognize is that this is not a technology that needs to wait for a large nationwide or continent wide carbon dioxide distribution system. We believe that the co-location of capture and use is one of the early critical elements associated with uh, the deployment of these technologies. Um, there are lots of examples of this. Most of the um, aggregates that are being done right now, for example, carbonate in the Great Britain, they're modular units. They go to a place where they have to immobilize uh, hazardous materials. And the plant goes in, it's a modular unit, it uses carbon dioxide in order to be able to do that. So, this idea of co location gives the opportunity to put it near the use, but it requires that one think about not just transformation, but also the capture of carbon dioxide. And I think I gave an example, the naval example associated with this. How do you generate aircraft fuel on an island, for example? These are the places where the early adopters are. We all recall what it was like when solar panels were very expensive, that the only productive place you could put them or cost effective places where you couldn't run an extension cord, like a satellite. But we've come to the point where it's one of the least cost capital intensive options for energy at this stage. And this points to the last point that zero carbon energy becoming increasingly available is, in fact, incredibly important. And we have many ways in which we might use that. Most popularly, people like to think about storage, but these products may, in fact, be an important way to encapsulate the energy and enable the early deployment of these infrastructure, these technologies before there is a large scale infrastructure and may, in fact, be the method by which they're deployed in the long run.
So, another opportunity for you to test your knowledge or your guessing ability. True or false, the number of CCU product developers has increased at the same rate from 2016 to 2021 across to all TRLs.
Okay, so we clearly have the winning statement to be this is not a true statement, and if we look at the review that we see here across the technology readiness spectrum, we see market difference at the entry level. Low technology readiness level newcomers are certainly much higher, whereas at the exit stage on this scale, we see little, if any, change in aggregate between 7 and 9. So this is good news. On the one hand, there is more activity entering that pipeline. We've always asked for. We need to fill the pipeline. But of course, a pipeline is only good if things flow. So efforts really need to put forth in deploying these technologies. In other words, moving them to technology readiness levels 7, 8, and 9.
And another poll, and I know you'll be disappointed, but this is the last poll we will do today. Which was the dominant category for CCU developers in 2016? And you can see this selection: building materials, carbon additives, etc. And then what was the same in 2021? What was the dominant category?
good. So there was a lot of competition between building materials and fuels. If we look at what I'm sharing with you here, two things are striking. There is a very uneven distribution, if we even want to put significance to that, between building materials and chemicals, food, and fuels. In other words, if we look on the left-hand side, all of those to some significant extent could be called track 1 materials, whereas track 2 materials are chemicals, food, and fuels. So not only have the numbers been higher back in 2016, but also the most significant growth in new development activities happens in track 2 materials. So that is really an interesting observation, because as we keep emphasizing during this talk, track 1 materials have the higher climate significance. So something to take note of in that sense. So how does that translate into investment interest? Looking at the last 10 plus years, not too much has happened of significant change until 2021. In 2021, the amount of venture capital funding that went into carbon capture and utilization technologies really increased significantly. And it again is true that the most significant amount of funding actually went into chemicals, food, and fuels. So, of course, reflecting somehow what's available to be invested in. Big messages here. Venture capital influx is increasing, but we certainly need track 1 materials to receive additional attention. So what can individual groups do is something that we want to share with you now.
So I think the first question is, we just talked about technology developers, and there are a large number out there. And I think that there are some important lessons from what we've done that kind of informs the technology developers. The first of these is to always recognize, whether it's for construction materials or for chemical products, that standards exist. The purpose of development is deployment, and you need to understand the environment into which you're in fact deploying. So for construction materials, the structural strength of concrete, these things are important. They're important for safety and so on. What is the characteristics of jet fuels? As you're doing these developments, you need to understand that deployment may require certification, and you need to bear that in mind along the way. The second point is that getting things into practice is critical. And we believe that, as we mentioned before, that one of the critical elements of that is co-location of capture and utilization facilities. So when you're doing a development, are you going to buy carbon dioxide from the guy that generates it from methane by burning it? Or are you going to build it up so that you're in fact integrating it with a carbon capture unit? Carbon capture units are increasingly modular. There are a number of companies that in fact produce them. And as you get to the demonstration phase, it's really important that early deployment technologies, those that technology developers are most interested in, need to look at the integration of these and co-location of these facilities. And finally, products need to have the confidence and trust of the public and of the people that are in fact supporting them and buying them. And standardized life cycle assessment to guide development is important. It illustrates the value, it illustrates the impact, and not only for the environment, but the social impact as well. These tools are in fact important. So remember that standards are there. Remember that early deployment is in fact important, and integration and co-location may help that. and following the standards that are necessary in order to prove the efficacy of the technology is extremely important. Fred, what about the private sector?
Thanks, Jerry. And the private sector can do what it does very well. That is, it can create shareholder and stakeholder value through commercialization of valuable products and then innovation and effective cost management to increase productivity and reduce costs. We know that many corporations have committed to achieving net zero. And one way that they might do this, of course, is to use offsets. But as is increasingly apparent, there are real problems with offsets. Those include things like true additionality, permanence, and certification. So another way to achieve net zero is to, in fact, take fossil carbon out of your products by using captured CO2 as a feedstock. And if your production operations emit CO2, you can capture and use it in products. Achieving zero carbon will require zero carbon energy and zero carbon hydrogen, and you can begin now to develop these sources. Viable CCU products will require, as has been already mentioned, the formation, the establishment of an entire industry, from suppliers to logistics to users. This is a nascent industry, and you can be instrumental in building it and in therefore reaping the benefits. Now, we know that building an entire industry is too large for any one corporation or any one investor, and therefore consortia and public-private partnerships will be a key. And as we have mentioned, we do have the opportunity to learn from the mistakes of our past. And happily, we now have the tools to assure that actions achieve goals without unintended consequences. Each project should be subject to the life cycle assessments and societal considerations that Jerry just mentioned. Volker, what about government?
Yeah, there is certainly a lot that we ask governments to consider to help build and operate this industry. But that's something that governments have been doing for a long, long time. But I think what's a different element entering that scenario here now is, of course, the speed at which it needs to happen and the potential impact that it has on communities. So ensuring transparency to guarantee benefits and make sure that environmental and societal justice is maintained is critical. Otherwise, consumers will outright reject any CCU process, no matter how useful it might be in the context of climate change mitigation. So we have heard repeatedly now today that co-locating of capture and utilization is something that can accelerate deployment, and of course that is something that can also be incentivized by government. But I think what's especially exciting and interesting is this classification of CCU products in track 1 and track 2. That creates a fairly simple way of labeling products to highlight the climate impact, and that helps guide policy decisions. On the other hand, of course, you remember that we have chosen 100-year lifetimes as the cutoff between these two tracks. nobody, in fact, knows the true and full climate impact of what would happen if we have our economy, our economic needs, our societal needs covered by CO2-based products. So integrating those into not only economic models, but also climate models is going to be a key priority to make this meaningful. And in that context, of course, given that we have a global problem, international collaborations can actually help accelerate. You've seen that in our assessments work that interesting and important synergies are being built on. But that's not all that we suggest governments should consider. Of course, we have highlighted in previous slides that procurement opportunities are large. Governments are very often the largest purchasers of services and goods, and no different, for example, for concrete or jet fuel. In that sense, major customer here too. And if we look at the investment community, what's really critical for them? It's absolutely essential that there is stability in policy. There's stability in instruments that help launch this industry, so that people are going into it and have confidence that this is something that we stand for as a society. And that is also manifested in helping to build up public-private partnership, joining forces and doing this jointly to get this off the ground quicker than if we wouldn't produce this in concert. We, of course, have emphasized that we want to co-locate capture and utilization as much as possible. But that doesn't mean that we don't need any infrastructure. There's more to infrastructure than pipelines. There's the capture facilities in of themselves. There is some transportation perhaps still needed on a smaller, shorter scale. And clearly, infrastructure in the CCU context will have to include zero carbon electricity and hydrogen. And of course, both of those are not primarily developed and deployed as we speak for CCU alone, but for the broader needs of societies. So here is a good complement between efforts. And as in the past with other industries, other technologies, the impact of government funds in the form of loans and tax incentives is very powerful to launch industries, to create jobs, and to get this done quickly. That is certainly an important element. So where have we come with CCU opportunities since we last put out a major report in 2016 on this topic? We continue to believe, and I think we have even stronger evidence now, that carbon capture and utilization is a critical element of the solution set to address climate change. And it is especially powerful because we can make the things we need every day, things that cannot be made without carbon. And in the process of creating that trillion-dollar industry, we need to train a lot of people to actually make the goods that we need to make. And therefore, the solution here is bringing a lot of economic benefit in many contexts. But critically important, key reason why we're doing this is that it adds to a reduction in net emissions. That's really, really important. And today we have shared with you that aggregates, precast concrete, jet fuel, and methanol production from CO2 are ready for deployment now. We need to massively move forward so that moving towards a commercially significant scale, we can benefit from an associated reduction in cost. And our firm belief is that a key step to enable that and launch quickly is in that co-location of capture and and use, along with the energy and hydrogen needs that are associated with this. So before we take questions in the last couple of minutes and share the source of the report, I want to point out that a lot of the time that we spent on producing this report, we closely interacted and benefit immensely from research and analysis assistance that we have received from Lux Research. In particular, Yuangshen Yu, Ari van Berkel, Renil Daya, Oscar Games, Cecilia Guy, and Mukundu Kaushik have worked with us for almost a year on this. But first and foremost, none of that would have been possible without generous support that we have received from our College of Engineering, where the Global CO2 Initiative is housed at, here at the University of Michigan. So I would like to open this up now to a few questions, and I think I let Fred choose the questions that we managed to address. We can certainly save these questions and answer them offline, post those answers. And we definitely also want to point out that you can upvote the significance of questions.
Thank you, Volker. So I am reading through the questions here. A first one says that what is the current status and trend of the discussion on CCS, that is storage? Is CCU more of a viable option now? And yeah, I think I can take that one and say that based on what we've just presented, we are very much confident and excited that CCU is part of the solution set. And as Jerry talked about, we talked about with type 1, with aggregates and precast and building materials and others, we look at that as being the intersection between CCS and CCU. That is, these are valuable products that can sequester carbon for at least 100 years and quite possibly much longer. The next one has to do with polyurethane and why it appeared between formic acid and methanol in the market penetration chart. That Volker, if you want to take that one, otherwise we may do that one offline.
Yep, happy to, and we will certainly have to revert to answering most of the questions actually offline. I know we're over time. I see that people are moving away, and I do want to take the opportunity to share with the participants where they can actually read more, including a detailed assessment about polyurethanes. And clearly, the market predictions and market forecasts depend on a number of factors. And we discuss those in greater detail in the written reports. And perhaps at this stage, we should give access to where the report can be found.
I think so.
Thanking our audience and my tour during Climate Week in New York, even though we joined from Ann Arbor, Michigan, Philadelphia, Pennsylvania, and Greenland, New Hampshire. It's been a pleasure to have everybody on the call. And I'll close with sharing where you can actually find the reports. It's a summary report that sort of aggregates what you have heard from us today, and many, many more details in that second document shown here on the right. Feel free to download them at your leisure. They are freely available, and we allow them to be shared broadly because we need everybody be on deck. Everybody needs to chip in and help address this climate problem. At the same time, realize the opportunity that lies within utilizing CO2. Thank you so much, everyone, for attending.
Thank you.